My name is Jonathan Watson, and this is my MEMS 5001 final project. There are 14 schools that make up the SEC, and these schools have games scheduled over a 14-week regular season. Our goal is to find the optimum path to visit every college once during this span, limiting the total distance traveled over the trip. To begin, some initial conditions that were made for this problem. First, all the paths that did not lead to seeing a home game in each week of the regular season were eliminated as possible solutions from the traveling salesman portion of this problem. Second, for this example, St. Louis, Missouri was selected as the start and end destinations for this trip. This may be typical for this style of problem, but for the applications of this project, we can assume that the vacationer is a retiree or has the ability to work remotely during this 14-week journey. The last initial condition set was the group traveling were alums from University of Missouri and Texas A&M University. So the group wanted to begin their journey at week 1 at Texas A&M and end with week 14 at University of Missouri. This makes the project a little more personal and can be varied for future applications. Since Ole Miss was the only team to play on Thanksgiving, this game is another that sets a fixed week in week 13, even though it's just an outcome of this year's schedule. The locations of all schools were imported from an Excel file that was constructed with name, latitude, and longitude in the first 3 columns respectively. This import is what the traveling salesman code would use to calculate the optimum route. The SEC schedule was imported into the script and changed to a binary matrix with 0s representing away games and 1s representing home games. From there, a schedule matrix removed all rows that had a 0, indicating that there was a week that resulted in no home game at the school visited that week. The minimized route matrix was then checked against the possible schedule matrix to yield the optimized route for the season. The results are shown in the table on the right of the screen. We start in St. Louis, Missouri, then go to Texas A&M, Arkansas, LSU, Alabama, Auburn, Florida, Georgia, South Carolina, Tennessee, Vanderbilt, Kentucky, Mississippi State, Ole Miss, Missouri, and then back to St. Louis. A breakdown of distance traveled and drive time are also provided. The last row totals the distance and time associated from driving the entire trip. The trip's distance is 4,990 miles, while the time taken to travel via car would be about 77 hours and 23 minutes. A map of the trip is detailed on the right of the screen and shows the most optimized path after schedule restraints were placed. As you can see, there were a couple of weeks that require a further drive due to no home game that week, or just that the next closest college has already been visited. This figure shows the true optimized path between the colleges, and one can see how it sets up a slightly shorter drive in total travel distance. Again, though, this path was ruled out due to some schools along the path not having a home game on the week visited. Some future considerations for this style of problem may lead to good ideas down the road. For example, small changes to the code could make it more versatile. Elimination of the scheduling constraints could be one path, but that leads you to a generic traveling salesman code. My idea for future use of this code would be to create an app that uses the schedule constraints for other sporting events, or for vacationers to import data on when certain attractions are open and closed on certain days. Here is a list of my references used on this project.